Welcome to the Science Gateways Community Institute webinar. I am Catherine Lawrence, and I'm with the Science Gateways Community Institute, as you might guess. We ask you to keep your audio and video off if you're, other than the presenters, of course, just so that we have a good view for the recording that we'll be making of this. You can submit questions through chat at any time, and I will share those with the presenters at the pauses between each of their different chunks of the presentation. And then this is, as I mentioned, being recorded. So we will have that up along with the slides within a couple of days. I also want to mention before I talk a little bit about Science Gateways Community Institute, that we have a program called Gateway Focus Week, and it is an intensive program. It used to be a week when it was in person. This one will be virtual, and today is the last day to register for it. It's free, and it basically helps gateways think through what might be considered to be the sustainability and business planning side of what they're doing, which is often very helpful for PIs who don't come from that kind of a background. So with that, I just want to tell you a little bit about the Science Gateways Community Institute. We're funded by the National Science Foundation to provide support to gateways in several different ways. The first way that we support gateways is through for building and running gateways, and that includes hands-on development support, advice from consultants on topics like cybersecurity and usability. And then we also have a catalog of gateways and software used for building gateways, and we encourage gateway projects to list themselves there. And the second way that we provide support is through education and training. That, of course, includes this webinar series. We also, and the Focus Week that I just mentioned to you, we also have student-focused programs, and our website resources include a lot of educational stuff. And then finally, we are all about networking community, because community is in our name. We have an annual conference that brings together gateway creators and users to talk about their craft. We have a community forum that you can join if you want to reach out to other gateway developers and get their input about things, and an ambassadors program and a collaborators program. With that, I have one remaining question or request of you, which is that we do like to be able to demonstrate to NSF that these events are valuable. So please do give us feedback at the end. I'll be posting this link to this very quick survey. And this is a great way also for us to hear from you if there are certain topics that you'd like to hear. So that is the most important little wind up part of this that I hope you'll join us for. So with that, I'm going to hand this off to our crew of several people from the Delta Project. And to begin with that is going to be Tim Borner, who is going to start the series of things.
All right. Thank you for that introduction, and thank you everyone for coming out today to this webinar and being interested in hearing about the Delta system that is going to be coming online at NCSA here in the fall. So my name is Tim Borner. I'm a Senior Assistant Director at NCSA, and I'm our Deputy Project Director for the Delta Award at NCSA. So what is Delta? Delta is an NSF-funded computing and data resource. It's through their Advanced Computing Systems and Support program, and it is a Category 1, which is called Capacity Computing Resource, which means we're targeting as broad a swath of the science and engineering, research and education community as we can with this system. So the name Delta is a reference to the Greek letter delta, which in many scientific equations means change. And so when we were putting this idea together for this resource, there were three key areas that we were anticipating, or we saw interesting change over the last many years in the computing and data ecosystem. And we wanted to make sure that in the work we put into Delta, we were contributing to these valuable areas of change and participating in the community and advancing objectives in those spaces. So those three areas here are compute, data, and interface. On the computing side, you can see we note furthering GPU adoption. There are many domains and applications that have been taking advantage of GPUs for accelerated computing for many years. We want to continue working in that space. On the data side, we're looking to move into beyond POSIX file systems into more modern and tailor-made file systems for large-scale computing resources. Last here is the interfaces, which is perhaps the most interest to this group here. Delta has a very large interest and component to it that is about advancing the usability of the resources and supporting the Science Gateways community and integrating with as many Science Gateways as we can, as well as interest in the accessibility of these resources by individuals with visual or other types of impairments. So I'm going to dive into a little bit of these three different areas and then talk a little bit about our leadership before I hand off to Brett Bodie, who is going to talk about the system itself. And then once he's done, he'll hand off to Greg Bauer, who is going to talk about our application and user support elements. And for those of you who are also thinking about attending the Exceed webinar that's going to be happening in about 2 hours, you should probably know that we're going to be presenting this same content there. So if you're looking to attend both, you might get some duplicate information. Or if you really think the presentation is that amazing and you want to hear it twice back to back, then come on down and ask all the good questions. Okay. A little more detail on our compute vision. So furthering GPU adoption is something that it's not necessarily applicable to all applications or uses, but there are many that have seen great advantages in acceleration, GPU acceleration for their codes. And we did a lot of number crunching when we put the system configuration together and saw that there was a pretty significant and growing gap in the demand for GPU resources across Exceed and the availability of those. And so we configured Delta to be the largest GPU resource in the NSF portfolio at its launch. You'll hear more details about the specifics, but we'll have 848 GPUs of a mixture of a variety of different kinds, so single precision and double precision GPUs to make the system more usable across a wider variety of applications and use cases, and sort of a tool for everyone in their science workflows. The program's going to continue the hard work of adapting applications for GPU computing. So you can't just run your application on a CPU, then take it over to a GPU and run it. You have to do some work to get it to port over to the GPU to function effectively and efficiently there. And so we'll be working with teams to do some of that application porting and tuning. We do plan to rely heavily on Exceed's ECSS service for as long as we can. When we put the proposal in, we anticipated the successor to the Exceed project as continuing that effort. But it appears as that solicitation came out earlier this year that ECSS is not really a component of the successor to the Exceed project. So we'll have to be figuring out alternative ways of meeting some of these needs on Delta, and the community will be looking for solutions there as well. Last year, you'll note that we're planning not just to wait for GPU use cases to come to us. We've got some effort funded to survey the community and to look at usage of GPUs across predominantly the Exceed ecosystem and Science Gateways for new and emerging research domains that are starting to take advantage of GPUs, and to sort of proactively reach out to them and see how we can assist in getting them using GPU resources. On the data side, moving beyond POSIX, that's sort of the Unix-based file system standard for and has been for quite some time, but strict adherence to a lot of the particulars of the file system can be pretty challenging for large-scale parallel systems, and in many cases, it's not actually necessary for the applications to run. There's strict rules about locking and access of files in a parallel system can cause reliability and performance issues. And to look beyond that and show ways to address this for these types of systems, we're going to deploy both a traditional POSIX file system, but also a non-POSIX file system that will present a POSIX-like interface. So it will look like a traditional file system, but underneath it will behave very differently. And so the term we're using is POSIX Lite, but technically it's sort of mimicking that interface. The upshot is that most applications won't need to change in order to take advantage of the performance and reliability of the new file system. And we're looking forward to seeing how that plays in the sphere of parallel computing. All right, on the interface side, we have partnered with Science Gateways Community Institute. There are several award on the NSF grant from NCSA to SGCI. There are several award and working with us on developing our story and the technology that we'll be deploying for our Science Gateway interfaces. With Delta, we're planning a rich variety of interfaces. Command line is sort of the norm for many communities that have been using these types of systems for a very long time, but there's such a rich variety of new interfaces available through Open On Demand, which is more of a portal front end for a computing environment, to the wide variety of gateways that are available represented by this community. We're really looking to support as many of those as possible on Delta. And so we want to hear from you all, from this community, on ways that we as a project that delivers an advanced computing and data resource, what can we do from our operational perspective, policies, and others that will really work well for the Science Gateways community. We want to hear about Science Gateways that are interested in taking advantage of the resource itself, and ways that we can support that. One of the things SGCI will be doing in partnership with NCSA is developing a gateway interface specifically tailored for Delta and its user community. So we'll be developing that as we get into swing with the project overall. So other things we want to see coming out of Delta in this space are practices, operational practices, and for the blending of a traditional batch computing environment with interactive use and on-demand use that you would see through Science Gateways, as well as visualization and some other use cases. So we're trying to look at some ways we can do that. There's some advanced features of the new GPUs that Delta will have that lets you split them up and virtualize access to them, that we're hoping we can leverage to make this a more seamless experience for everyone. Last year, you'll see we have a University of Illinois researcher that we're partnering with, and we'll fund a grad student for a couple of years to do a full evaluation of the interfaces for Delta for accessibility and usability by people with visual or other impairments. And we're going to take the output of that study and improve the accessibility of Delta and make the findings of that available to the community, and hopefully to the betterment of all. So, but lest anyone doubt that it's sort of lip service on the Science Gateway side, we actually took the time to create an entire Delta Science Gateway vision that I'm not going to read out here because some of you might fall asleep, but we'll have that in the slides for everyone to look at later. Okay, some quick notes on project leadership. Our PI and project director is NCSA's director, Bill Gropp. On the co-PI side, we have Greg Bauer, leading applications, who will give the third part of this talk. Brett Bodie, leading systems and infrastructure, who will give the next portion of the talk. Myself there, deputy project director, Tim Borner, who will stop talking very soon, much to everyone's pleasure. And last but not least, Amy Schul, who's leading our accessibility efforts. And just note here at the top that we do have other elements of our project leadership that are participating from the Science Gateways Community Institute itself. So with that, Brett, do you want to go ahead and take over? Or do we want to pause real quick for a couple of questions? See if there's anything.
So far, no questions have popped up yet, so I will keep an eye out for them for later.
Then I will hand over to Brett.
All right, thank you, Tim. So as Tim introduced me, I'm Brett Bodie. Have been co-PI and assistant director on the Blue Waters project, and a co-PI on Delta, working on the systems part of the project. While my background is quantum chemistry, mostly I'm working on the technical computing side of things today. So I'll give you a quick overview of the hardware for Delta. And one of the things you'll note with this kind of 10,000 foot view of the system is that the individual components in Delta are things that you're going to see or already see on other systems around the NSF and DOE spaces today. In particular, the components that we're putting in Delta are pretty much very similar to components going into Anvil at Purdue and will be in other systems as well. So we're using HPE and DDN as our primary hardware vendors, with compute elements from NVIDIA and AMD. What's a little bit different in our system from other systems is there's a number of systems, particularly in the NSF space today, that have mixed CPUs and GPUs, but those systems are pretty much exclusively focused on CPUs with a relatively small number of GPUs on the system. We've kind of flipped that model, as Tim indicated. We're focusing on the GPU side of the computing space. So we've put most of our funding, at least, into the GPU parts of the system. So we have a large number of GPUs, and actually we'll have the largest number and largest GPU capability in the NSF space when we're deployed, as Tim already indicated. And then we augment that with a reasonably capable slice of CPU only nodes to be able to handle the CPU only portions of workloads. So what we have overall is 124 dual socket AMD Milan based CPU nodes, along with 8 very similar configured utility nodes that will run a large variety of services that I'll talk about in a little bit. Our GPU nodes are split into actually 4 different types of nodes. The Workhorse nodes are 100 64-bit GPU nodes, which will have A100 GPUs in them. 100 32-bit optimized GPU nodes, which will have NVIDIA's A40 GPU, which I'll talk a bit about in a later slide, as well as 5 nodes with 8 A100s and 2 terabytes of memory, and 1 node that we're offering as a way to work on portability, with it will have 8 AMD MI100 GPUs in it. Those are combined with 7 petabytes of disk-based storage provided via Lustre file systems. That'll be available day 1, and then early in 2022, we'll be adding 3 petabytes of flash-based storage, which will increase our bandwidth to storage by almost an order of magnitude. And that'll be the primary focus for the relaxed POSIX storage as well. So overall, we'll have a fairly capable system with over 800 GPUs, with 10 petaflops of double precision performance, 100 petaflops single precision, and 200 petaflops of tensor capability. As I mentioned, the Workhorse nodes are the 64-bit GPU nodes. So these are quad A100 nodes. They have a single AMD Milan-based 64-core processor per node, with 4 NVIDIA A100 GPUs, all with 40 gigabytes of HBM2, and all connected by NVLink. So these nodes should have good scalability both within the node and outside of the node, as well as good bandwidth to storage, and should handle a wide variety of existing and new GPU codes, ranging from molecular dynamics codes to AI ML codes like TensorFlow and PyTorch, and of course would be a very good target for porting new codes. We also have a very similar set of, to advance, there we go, of 32-bit GPU nodes. These have the same host configuration, but instead of A100s, they have A40s. So these do not have NVLink connecting the GPUs. They're a cheaper version of the Ampere silicon that does not have the 64-bit capability, but does have very good 32-bit capability, as well as a unique ray tracing capability that should be very useful for some types of visualization applications. So these will be available on a from an allocation basis, they will cost less to run on these than it does on the A100s. And so they'll be useful for codes that get more bang for their allocation cycle out of these codes. Will allow us to have more capability in the system overall. I mentioned the dense GPU nodes. So these are, again, A100s, 8 A100s fully connected by NVLink with 2 terabytes of memory. So they're obviously targeted for either applications that require a dense GPU node that doesn't scale outside of the box, or large data problems that need the 2 terabytes of memory in a single box. So we have 5 of these nodes, and could be used for a variety of problems. And then we're augmenting that with this node has the same host configuration as the 8-way A100 nodes, but instead of A100s, it has 8 MI100s. So these are the MI100s have a infinity fabric that connects them in sets of 4s, but should be a good porting platform. They'll be in some ways, very similar, capable to the NVIDIA GPUs in certain aspects of their performance, but it'll be a good porting platform both for AMD GPUs elsewhere, such as at DOE Labs, as well as for future AMD GPUs going on. And we also, AMD will be providing containers with optimized versions of software like TensorFlow and PyTorch that Greg will talk about a little bit. That should allow us to get up and running on the system very quickly. The CPU nodes are the Workhorse nodes that HP is providing. They're Apollo 2000 based chassis, so 4 nodes and 2 U's. Each node is 2 sockets of Milan 64-core Milan processors. These are liquid cooled, so they should be very stable in terms of performance relative to load. And all the main compute nodes have the 256 gigabytes of memory and some amount of solid state storage within the node for local OS and a little bit of Scratch. So these are intended mostly for augmenting GPU allocations. And so we know that most workflows have, even the very GPU focused ones have some portion that needs some CPU only capability. So this lets us use a cheaper platform to get that done. You'll note that all Milan processors throughout the system have the same performance, same number of cores. So there's no difference in CPU performance on any of the nodes. This goes also for the utility nodes, which are also similar to the CPU nodes. They're in a slightly different enclosure, but otherwise are the same performance, same sort of system. These will be used for both logins, data transfer nodes. They'll provide routing. They'll also offer a capability for persistent services for user tasks for things like databases or workflow engines that need to have some persistence beyond a single job. And we'll work with teams to figure out the best way to deploy those services on these nodes. The storage environment will be provided by DDN. As I mentioned initially, it's 7 petabytes of spinning disk with 6 petabytes locally attached to the system and 1 petabyte that will be mounted on our NCSA center-wide file system for shared project storage. They will provide flash storage for metadata, which should enable faster metadata operations, and then will be augmented in 2022 with the 3 petabytes of flash-based storage. That'll provide, again, a nearly 10x increase in performance, and it will certainly be the place to put large data sets and very IO-intensive data sets. And we'll work with teams once we have the flash in-house to test their applications out on the relaxed POSIX interfaces that we'll talk about later. I will note that while we don't have a great amount of storage, the center-wide file system does provide storage as a service in addition. So we'll allocate the 1 petabyte of project-based storage as best we can. But if we're unable to provide allocations in there and projects need more, they do have the option of running more space on that center-wide file system. The network for Delta is a Cray-designed HPE Cray slingshot network. So it will be 200 gigabits per second per node once it's fully configured. The system is set up so that each slingshot switch provides connections to up to 32 nodes. And then that each switch is connected to all other switches within the system, providing an all-to-all connection layer at the switch level, which should provide a very good performance throughout, very high resiliency to any sort of faults as well. The external connectivity for Delta, Delta will have the 8 utility nodes directly connected to an aggregation switch with 200 gigabit links to our infrastructure at our data center. The data center is then connected by 4 100 gigabit links plus some 10 gigabit links to national networks in Chicago and beyond. So connections to Internet 2, to Exceed's network, ESNet, and others all have very, very high bandwidth, low latency connections. And we believe that we will be unlikely to be the bottleneck for data transfers in and out of Delta. Usually it's almost always some other site. And with that, I will end my part of the presentation and turn it over to Greg Bauer to talk about the user and application experience.
So there is one question that came in that might actually be answered by what Greg is about to talk about. But the question was about whether, from Joe, as to whether NCSA is planning on offering training events for transitioning to ROCM, if that's how you say it, ROCM.
Yeah, to ROCM. Yes, I think the plan will be to provide some training. At the moment, we don't have in-house expertise, but we will hopefully be developing some of that and working with AMD to provide some vendor-based training. So hopefully we'll be able to satisfy that interest, yes.
Terrific.
But thanks for the question. All right, so I'll continue on. If I can get my slide to advance here. There we go. All right, so as Tim and Brett have alluded to, Delta will have hopefully a very rich software environment for people to use to help move their applications from other Exceed or other compute resources elsewhere as part of either through a gateway or through a normal process or Exceed process. We will be providing access to the usual set of suspect HPC type programming environments, including GNU and Intel, of course, AMD with their AMD optimizing compiler and support for ROCM, and NVIDIA released last year their HPC SDK or development kit, which includes now what used to be called the Portland Group compilers, which offers support for OpenMP and OpenACC based codes. And probably what might be unique to Delta will be support for compilers and programming environment for Cray, since HPE acquired Cray a little while ago. Our experience with the Cray programming environment on Blue Waters has been very successful, and Cray provides performant compilers, mostly for, I would say, Fortran or support for OpenMP and OpenACC, and would do well on our system. And we realize probably not too many teams will want to use that initially because it does limit portability, possibly if you're having to port to one compiler that may not be available at too many other systems. As part of a broader movement, kind of initially started by some of the national labs, and it's been picked up recently by our colleagues at San Diego at SDSC and over at Purdue, is the use of software package management systems on the user side. So we will be working with folks to use SPAC and EasyBuild to deploy our third-party software, and we're going to highly recommend, where possible, that projects that are coming to Delta to also implement their software deployment mechanisms using SPAC or EasyBuild to help rebuild software when we have to do system updates that require applications to be rebuilt, and that'll reduce the complexity and the time it takes to do updates, hopefully. Like most other Exceed sites, we'll be using modules. So most gateways that have to customize their environment on the system, you'll probably see the same modules. We'll try to work, we'll have a goal to make our module environment look as similar as possible to San Diego and TAC and Purdue with Anvil, so that people can easily, so that gateways can easily move their communities to different sites. And as Brett alluded to earlier, we'll be providing support for containers, initially with Singularity and possibly looking at other more current container support environments. One thing we are considering, and we've heard this from some of the feedback from our interviews with current and existing Science Gateway developers, is that they would like to see the ability to mount images on login nodes to help improve their development process. So we'll be looking at that. And we will be making available containers provided by our vendors, NVIDIA and AMD. And we're also entertaining the possibility of deploying NVIDIA's container maker, which makes it easy to build containers locally on the system and targeting applications that use the GPU. So hopefully that'll prove to be beneficial and very efficient. And as Brett mentioned earlier, we will be looking to support as much as possible what types of persistent user tasks that need to be supported. Brett already alluded to a few work, such as workflow orchestration, maybe some long-running processes for supporting databases or complicated data transfer scenarios. Since one of the primary focuses of Delta is the implementation of gateways, Tim alluded to our partnership with SGCI, and so we're working very closely with them on a couple fronts. One is to develop a Delta-specific gateway, which the details are still being ironed out, but hopefully that will allow more and more communities to move their codes to a gateway and make them available to a broader set of users, and lowering the bar to getting access. And along with that, we'll be working with teams to hopefully adopt GPU acceleration, such as moving over to possibly using our small resource, which is the AMD MI100 node that we have. And as Tim mentioned too, our goal would be to see how many gateways we can support on Delta and bring over as many users as possible. And hopefully we can develop a scalable support mechanism for that. And as part of that process, Jay Alameda, who's on the call as well, and Claire from SGCI, and occasionally myself, have been on many, many interviews, interviewing candidate gateways and candidate communities that could participate in this effort. Oops, did I double click here? Sorry about that. Probably one of the things that's probably on a lot of people's minds is how do I get access to Delta? And some of that will be through an exceed allocation, and the window for exceed allocations opens up again in, the proposals are due by June 15th, I believe. And when you look at the RDR information for Delta, you'll see three different types of allocatable resources. One will be the primary will be the Delta GPU resources Brett and Tim mentioned. But also you can request resources that are CPU only in support of your hopefully GPU-centric workload. And of course, you need to request storage allocation for storage. And we'll discuss a little bit about quotas in the next slide or two. One thing to keep in mind is that, and as Tim alluded to earlier, we are trying to focus on GPU-oriented workloads. And so the CPUs are primarily for in support of workflows that have codes that only run on the CPU, but are able to also have parts of their workflow run on the GPUs. And as was mentioned earlier, we expect initial allocations to start sometime in October. So access to Delta, how do we envision connecting to Delta? Well, of course, we'll support traditional SSH. Plain SSH to Delta will be done through multi-factor with an NCSA Duo, two-factor or multi-factor authentication mechanism. We'll also support Exceed single sign-on mechanism, which is an SSH through their SSO using Exceed Duo multi-factor. So the two Duos, as you know, Duo are not federated. So we'll have to have separate Duo instances depending on how you want to come in. The compute nodes will be accessible, at least initially, by initiating external connections from a job, for example, or from the service nodes. Open on demand will be available as well. And as we alluded to, those will be running on service nodes and then be able to submit jobs and get put onto compute nodes. And of course, we'll be doing a lot of our authentication using CI logon. For gateways in particular, we'll support the primary mechanism of using SSH with keys and host IP restrictions. And we'll also, of course, have support for the gateways that have community users. And we'll also be working with all the gateways with their particular needs for recording access and local usage information as well. For data transfers, as was mentioned earlier, we'll be using our service nodes for the larger data transfers, for making them DTNs using Globus or SCP or some other transfer mechanism that particular gateways use. And of course, for smaller transfers, source code updates and stuff like that, login nodes will be suitable for that. All right. Different policies that we're considering. So in this case, we're also looking for some feedback. One thing we have not defined yet are our policies for instant or on-demand access to compute resources. So we know that there's a need for quick turnaround of very small units of work. And typically we view those as kind of instant or on-demand access. And so we want to make sure we're able to provide a sufficient number of resources, either CPU cores or GPU slices. The one thing we didn't emphasize too much is that the NVIDIA A100s support a new concept of slicing. Its acronym is MIG, and you might hear that elsewhere. And it allows us to take one of the large A100 nodes, A100 GPU, sorry, and allocate by job individual slices. You can take an individual A100 and slice it into up to 7 individual pieces that can be controlled individually. So that allows us a bit more fine granularity for smaller workloads that don't have to use a whole GPU, for example, in a development cycle, for example. We haven't yet defined what our queue policy will be. We recognize that many Exceed sites have typical walk clock limits of up to 2 days, 48 hours, but that longer periods are possible using preemption. So we'll be looking at that and also looking at what kind of support's needed for longer running, what we'll call serial jobs, but they could be serial jobs running on a single GPU slice, for example. For scheduler settings, we of course will entertain various ways of implementing fair share to make sure that people are getting their work done. But we recognize the unique situation that gateways have, where a large number of users within a given gateway might be submitting a large number of jobs, but on the side of the point of view of the scheduler, it's coming from a single community gateway user. And so we have to make sure that we don't disenfranchise gateways by making sure that they're able to get their jobs through either interactive or through batch jobs. And then finally, looking at quotas on the file system, our initial quotas for home will be 25 gigabytes for the projects, the shared project space that was alluded to earlier, which will be on the system-wide, center-wide file system. Those will initially be 500 gigabytes. Or up to 500 gigabytes, depending on what you request. But then we will entertain larger requests as well, up to 25 terabytes. And for Scratch, we'll be looking at kind of defaults of up to 1 terabyte, but then based on request, up to 100 terabytes in practice. So one thing to note is that the Scratch file system initially will not be purged. We were hoping that we can maintain good usage of Scratch by the users of Delta, and we don't have to enforce any kind of purge-based policy. And one thing to note is, and this is pretty common in most systems, that the quotas for Scratch will be based on a project and not per user. For support, our collaborative services model, as was alluded to by Tim, will be looking heavily at Exceed. That was our initial concept for the proposal. Using ECSS mechanisms for support. And it was noted that ECSS will end sometime in April of 2022. And so if you are looking currently for support for moving applications to the GPU, we encourage you to consider looking at putting in allocation requests now on existing resources, such as Expanse, for example, or Bridges 2, and asking for ECSS support. And for porting to the GPU and at least getting that process started. So that'll be helpful in getting at least a toe in the water and moving forward before coming on the Delta. And Delta itself will be able to provide some assistance. We don't have a huge staff funding for this effort, unfortunately, but we are entertaining limited shorter term GPU porting engagements We will be offering as much training as we can. We know that that's probably the best and most scalable way to get more users of the GPU. So we'll be working with NVIDIA and AMD to provide as much training as possible, along with our Exceed partners as well, leveraging existing training such as that's provided by PSC, et cetera. And we'll hopefully be able to provide some assistance with gateway integration as well. So people have been asking, and we do have a mechanism for collecting information on people interested in early access to Delta. And we don't have a firm date for when that'll be, but since we're anticipating Delta to be in operation sometime in late fall, then we will anticipate the early access program will start sometime in early fall. We really don't know exactly when at this moment. Eligibility, well, to get the most out of that program, we need people who do have existing GPU workloads to run and help us stress all the different resources. And so hopefully we'll get projects that are ready to run on the GPU or nearly so. And if you're interested, you can send an email to help+delta@ncsa.illinois.edu, and we'll reach out and contact you for the particulars of your request. All right, and that's it. And now we are open for questions.
Terrific. Yeah, we have one question that came in. Actually, two more questions from Joe. Thank you, Joe, for keeping us busy. So Joe's first question is, for Singularity, do you have concerns over the Syllab/HPC NG split that has recently happened? There's a second part to that question, which is, does NCSA prefer the Syllabs or the community-based HPC NG fork? And I apologize if I'm butchering the language there.
That's a good question. So at least my limited experience with Singularity would not be that deep. And so I would need to defer to someone else at NCSA. So maybe Brett can comment on that.
Well, I can give an answer. It's not going to probably satisfy you, but we actually have been looking at different container solutions in some detail. At the moment, we haven't really considered all the implications of this split that you mentioned. And so at the moment, we're not going to take a position on it, but it is something we're looking at. But our current plan is some version of something, probably the Scilabs version of Singularity, but that may change. We still have a little bit of time before we complete the deployment to resolve which version of things we're going to use.
Okay, thanks, Brett. And then I can read the other one here. So unless you want to read it, Catherine.
Well, I just want to make sure, yeah, future listeners can hear it. So you can read it out if you'd like.
Sure. So this is another question from Joe, this one looks like a very helpful one that we'll take advantage of. How can other organizations get involved to help provide training to supplement what NCSA is offering? And I guess Joe has a small team with experience with ROCm, in addition to multi-AMD GPU applications would like to help. So certainly we would probably reach out to you, Joe. Sandy Kappas is organizing our training activities, and so she could reach out to you later once we get closer to late summer, I'm going to guess, and when we're actually have hardware on the floor and we're getting closer to being able to have people on the system. So that we definitely appreciate that offer, and we would reach out to you. So that you could probably just send email to help+delta and mention that, so that way we have a record of it as well.
Great. So, and Joe says that sounds great. So, we're welcoming more questions if you have any. I'm curious. A question that I have for you while we wait to see if others have questions is: are there characteristics of gateways that you think are would be a really good fit with the Delta project for using your GPU system? I know that certain disciplines or certain types of computations are better suited to GPUs, but I'm curious if you have any big picture advice for people who may not actually have that technical expertise to know when that's the type of thing to use.
So I guess maybe part of your question is, how do you know if you have a application that's suitable for the GPU? And that's a tough question to answer. Tim kind of mentioned that earlier. There are classes of applications from different domains where the the way that algorithms are implemented, they're not able to exploit the kind of symmetric multi-threading that the GPUs can offer.
Mhm.
Or there are other issues with branching where they're not able to take advantage of the enhanced memory bandwidth. So I don't have a good answer for that. Maybe we should consider some kind of mechanism where people can take a look and say, yeah, maybe I have a way to know that the algorithm, at least on the CPU. And I think I've seen some examples maybe from NERSC, for example, where they kind of, where they tried to come up with some hardware counters that you could collect on a CPU to kind of give you an indication whether or not your application would benefit. But with respect to applications that are GPU accelerated, any and all, we wouldn't discriminate, or we would prefer any and all already accelerated GPU applications from the existing ones that are out there.
Okay.
Any comments
oh,
from Brett or Tim to add to that?
Yeah, I'd like to add, if you've got applications that aren't taking advantage of GPUs in your gateways, and you're interested in seeing if it is the right kind of resource, and you want to just reach out to us at this email address and submit a ticket, we can have a conversation and have sort of a specific one-on-one kind of discussion about your application, and our team can try and help make some of those determinations with you if it's portable or not.
Great. I don't personally have a gateway to port, but I thought that might be useful for listeners. Another question came in from Alice. Do you have a preference for stress tests that use many GPUs at once, or many single node or single GPU jobs?
I think both would be great. We don't envision Delta as a high, at least when the workloads were viewed, we weren't looking at applications that would say use all the A100s across all 100 nodes at one time. But that's certainly something that's supported by the system, and certainly the network should be able to, the Slingshot network should be able to support that. So, but with respect to stress tests, I don't think it doesn't matter either way. I think both are just fine. So a good mix, I would say a mix. We would want a mix that would both test, make sure the NVLink's working well within a node, make sure the interconnects are working well, and the software, especially the software that allows for the optimized single copy mechanisms for between nodes, for example.
Great. She says the GPU accelerated software I use is currently limited to single node, which is why I asked. So great. So far, no other questions. I'm wondering, are there other kinds of things that have come up as you've been doing your various interviews or looking into further development of the Delta Gateway itself that you think would be useful for people to know about?
Hate to put Jay on the spot, but Jay, do you have any things that you want to mention to that question?
The most interesting thing has been those that have specific requirements for some persistent services or networking connections. You know, if they're connecting to another service from their gateway, those have been interesting, and of course whether or not they've had experience with GPUs. But those are the things that come to mind immediately, Greg.
Okay. I was just thinking also, like, what, you know, because it sounds like you're very much, even though you have a vision for where this is going, you're very much open to input from potential users and the community at large in terms of, you know, requests that they may have. So I'm curious if, you know, you've been surprised by anything that has essentially come your way where you've realized, oh, we hadn't thought about that, or oh, the field is evolving such that you know, we hadn't thought about this at the time we put the proposal in, but now that things are changing, you know, here's something else to consider.
That's a good question. I would say, you know, so certainly NCSA has been around for a long time in providing resources and working for users and working with different communities. But I think this is our first deep dive into a broader engagement with the Gateway community. So I think we're learning a lot with every interview. We've learned a bit about how complicated some of the workflows are. And so we're trying to make sure that we have all the services that are needed and make sure those are available. So I can't think of anything in particular, but I guess I would say that every time we have an interview with a different community representative or Gateway representative, and I know we can't interview all of them, but Jay and Claire seem to be on a goal to achieve outstanding discovery with interviewing lots of communities. That there's a, I think you name it, there's almost a need for something that that we need a provision. So we're just trying to make sure we can provide what we can.
Great. Looking to see, we haven't had any more questions come in. I could take a moment to tell a little bit about next month's webinar. Well, let's see if anybody else has questions, and then we could wrap up. So why don't I do that? So I just wanted to let folks know about next month's webinar. Let's see, can you see? Let's see, I think it should be showing, hopefully. We're going to be featuring the Tapas Streams API, which allows for real-time streaming data event-driven workflows. And that will be on June 9th. Oh, sorry, that I didn't change that. That's July 14th. Sorry. So July 14th. Don't get confused. I also want to mention too that Gateway Focus Week today is the last day to apply for the 2-week program that's going to be starting next week, and it's in the afternoons, I believe, to accommodate all time zones in the U.S. And teams can apply in order to participate in the various activities for that. So I will leave this up in case anyone has any questions or needs any information. And let's see if any other questions have come up in chat. No, they haven't. So I guess you guys answered things really well. So that's a good thing. So you can be prepared for your second Exceed webinar later on today. So so I guess with that, then I will we'll call it a wrap. And thank you, Greg and Tim and Brett and Jay, for sharing your expertise about this and this really exciting project. I think this will be a neat thing coming down the line for great gateways and science in general.
Great. Thank you all for making the time and giving us the opportunity to share an introduction to Delta with the community here.
Yeah, it's really exciting. And we're glad to be working with you guys too. So so as I mentioned, we'll have the recording and the slides from this posted in the next couple of days. So thanks everyone for joining us.